All right, let's talk about minimum spanning trees within analysis and design of algorithms. We'll do a brief introduction, see what is the main motivation for this problem, and present the main algorithmic solutions. So let's consider the problem of laying electricity wire connecting many residences to a central location. We could approach this as connecting each house to the central office directly, but that would be a very expensive solution because to dig wires from the office to each house might be very expensive. So a much easier solution is that we could minimize the total length of wire connecting the customers by connecting one house to the nearest house and then connecting to the central office. And that might give us what we will refer to as the minimum spanning tree. So formally speaking, given a graph G, a minimum spanning tree is a subgraph of an undirected weighted graph G, such that it is a tree. After all, we're calling it a minimum spanning tree. It is spanning, so that means it covers all the vertices of the graph. So therefore, it contains v minus 1 edges, and the total cost is minimum, the total cost associated with tree edges. So in this case, we assume that the graph is weighted, so we prefer the lower cost edges. We do not claim that such a minimum spanning tree is unique, but we do say we want to find a minimum spanning tree. There are many different applications of minimum spanning tree. We just considered the electricity distribution problem. We could also think of the internet content distribution, which is also a hot research topic. And in general, it solves many similar problems where we're trying to connect many different nodes to a central location, even if not directly. Another interesting application of minimum spanning trees is that you get a heuristic for traveling salesperson problems. And the reason there is that the optimum TSP tour is going to be no more than twice the length of the minimum spanning tree. And you can dig into that a little bit deeper. So how can we generate a minimum spanning tree? So we could use a variety of different algorithms. There are three main algorithms well known. There are many others as well. The original algorithm by Beruvka is actually the first known algorithm that solves this problem. It was described in 1926, followed by Jarnik's algorithm in 1930, which was popularized as Prim's algorithm in 1957, described again in 1959 as Dijkstra's algorithm. Around there, also 1956, Kruskal's algorithm, which is a different algorithm, is also very popular as well. We'll cover all three of these algorithms in different videos, but this is a brief introduction to the minimum spanning tree, which is a fundamental computer science problem. In some of those algorithms, we'll also see how different data structures can be modified to improve the time complexity of algorithms. And there are many similar problems which are actually not so simple as the minimum spanning tree in terms of their time complexity. Some of them are actually quite hard and are in fact NP complete. But that's a brief introduction to minimum spanning trees here.